Hello, everyone, and welcome to our Sustainability Week activities here at Cisco DevNet. So we have lots of good content for you this week. We are kicking off with our webinar on Cisco APIs for a Sustainable Future. My name is Adrian Iliesiu, and I will be your presenter for this session today. I'm a senior developer advocate with Cisco DevNet. I've been with the team now for almost 10 years, 10 exciting years. Looking forward to many more to come. So I cover basically enterprise networking, and we'll see today in our talk, I cover Cisco Catalyst Center, Cisco Meraki, iOS-XE, and then also Cisco Catalyst SD-WAN. So thank you all so much for joining, and we have lots of content to go through, so let's kick it off. The agenda for today is we're going to quickly talk about sustainability at Cisco. First, see what we do, what is sustainability actually, what is net zero. We're going to talk about some of those concepts and making sure we understand we're on the same page. Then we're going to jump into Catalyst Center APIs for sustainability. We're going to talk about what options we have there, the SDK that we have with Catalyst Center, Ansible collections, Terraform providers, and all of that. I'll give you some examples. Moving on to, after that, Cisco Meraki APIs for sustainability. Same thing, we'll have a look at the SDK, some API endpoints that are interesting and important from a sustainability perspective. And then we're going to wrap up with Cisco IOS-XE sustainability, and what we have with Cisco IOS-XE and the Catalyst series of switches. So let's jump straight in and talk about sustainability at Cisco. And you might be wondering, why did we start talking about sustainability now, right? So as you might know, the planet is facing threats like climate change, deforestation, and pollution that are affecting the lives of millions of people. So by adopting sustainable practices such as reducing carbon emissions and conserving resources, we can ensure a healthier planet for us and for future generations. So the importance of adopting sustainable practices is also reflected in a study that's been run by IDC in 2023 that showed that 63% of the companies that they interviewed, for them, sustainability is a business priority, while 37 of them have formulated the targets and sustainability goals. So that's important pretty much for all companies that IDC interviewed. And remember, no matter what anyone says about colonizing Mars or moving to the moon, there is actually no backup planet. We only have one, and let's make sure we preserve and take good care of the one we have. So where do you start, right? Where do you start with your sustainability on your sustainability journey? First, you need to set sustainability goals, right? Then you need to have metrics to measure and make sure you are on track to reach those goals. And then also that you have data about the impact that the goals that you have set have on the bigger picture. The UN has already produced a list of sustainable goals. So make sure you check that link that I have over there in the slide if you have if you need inspiration, or if you're looking for what sustainability means from the UN. So at Cisco, our sustainability goal is to reach net zero greenhouse gases emissions across our value chain by 2040. With some intermediate steps by 2030, right? So what is net zero, right? Net zero is the balance between the amount of greenhouse gas emissions produced and removed from the atmosphere, right? We know we cannot completely eliminate greenhouse gas emissions, but we can take measures to reduce them. And we can do that in several ways. We can start using electricity produced from low emission sources such as solar and wind. We can reduce emissions also by increasing our product energy efficiency, so making more power efficient products. and also by reducing waste through recycling and cyclic economy. So these measures to reduce emissions with measures to remove emissions from the atmosphere, such as forest expansion, direct air carbon capture, will help us to reach our net zero goals. So now that we have set our goals, right, what are the metrics? How do we measure our progress? Here is where the sustainability metrics come into the picture. So greenhouse gas emissions are classified in 3 categories or scopes for enterprises. So scope 1 is referring to direct emissions from fuels that we buy and burn within our enterprises, within our operations. This contains natural gas used to heat our buildings, backup generators running on diesel fuel and gasoline, and Cisco used vehicles, right? So our fleet of vehicles that we have at Cisco. Scope 2 includes indirect emissions from electricity that we buy for our operations, such as electricity we use in our data centers, in our labs, to run our equipment, as well as running HVAC systems and keeping the lights on. And then scope 3 is all about other indirect emissions related to our business that we don't own and we don't control. So this includes electricity our products consume after we sell them, our suppliers' energy use, transporting our products, and employee business travel and commuting. All right, so those are the metrics, right? Let's have a look at Cisco sustainability metrics. And for the year 2022, right? So as you can see in Cisco's case, the vast majority of the greenhouse gases are generated by manufacturing, procuring, and the usage of our products. We are lowering the emissions in scope 3, which is this year the biggest scope for us, by bringing new innovations at several levels, including increased power efficiencies with our Silicon One ASICs, increased performance per watt when you get the same amount of power or less. When for the same amount of power or even less, you get more throughput. We're adopting energy efficient Ethernet, IEEE 8.2.3az in our products. We're using sustainable materials for packaging. We're using sustainable materials in our manufacturing. And we have our product take back programs between many other things that we're doing. So we've talked about our goal. We've talked about the metrics. What about the data? What does the data say? So how much are we actually contributing to the overall greenhouse gas emissions overall? So as you can see in this graph, in 2020, we had reached a historical high of about 60 billion tons of carbon dioxide released in the atmosphere. So if we are to stay on track to only increase temperature by 1.5 degrees Celsius, we need to reach net zero by 2060. So digital greenhouse gas emissions, which include emissions generated by our networks, account for about 2 to 4% of the total greenhouse gas emissions emitted worldwide. And while you might think that is not too high, right, keep in mind that every single percentage point matters in the race to net zero. All right, so then keep in mind we have a dual role and responsibility as technologists, right? What is our role? First of all, we can lower emissions within our IT industry by using and optimizing renewable energy, by migrating to the cloud and using greener data centers, by extending the life of the infrastructure, and in some cases, use remanufactured equipment, or in other cases, migrating to more modern and power-efficient equipment. An even bigger impact, though, we can make by using IT to innovate, disrupt, and lower emissions for other industries, such as connected transport, hybrid work, e-health, e-learning, e-commerce, as well as smart manufacturing, smart agriculture, smart grid, and smart buildings. So at Cisco, we have several strategies to reach our net zero goals, including increasing the energy efficiency of our products and technologies, embracing hybrid work. We're big fans of hybrid work with our WebEx solution, accelerating the use of renewable energy, embedding circular economy principles across our business, and investing in innovative carbon removal solutions. And at that, actually, we have currently running a Build for Better Code challenge. And the topic this year, luckily enough for us, is AI and sustainability. So we have just extended the deadline for the submissions by 2 weeks until to May 6th. So if you haven't submitted your code yet, check out developer.cisco.com/build-for-better. And you can find more details on what this contest is about. We have some cool prizes. So make sure you check out if you haven't done so already. All right, so that's sustainability at Cisco. Let's jump in and start talking about Catalyst Center and the APIs that it provides for sustainability. So Catalyst Center, formerly known as Cisco DNA Center, is a powerful management system that leverages artificial intelligence to connect, secure, and automate network operations in campus networks, campus environments running the Catalyst series of switches. So Catalyst Center has several features. We're not going to cover all of them today. We're just going to talk about the Power over Ethernet power management dashboard that it has built in. So you can monitor your infrastructure that's being managed by Catalyst Center using the dashboard. You can see the Power over Ethernet enabled devices, their power consumption, and the dashboard provides information such as used power, remaining power, power usage. Very useful to know where you stand and to also plan for the future. You can monitor the switches, powers budget, and relays on streaming telemetry from Catalyst switches that is coming in through Catalyst Center. So what about, right? It's all good. The dashboard is there, works great. But what about if you don't want to use the Catalyst Center dashboard? You want that data, but you want to import it into your own monitoring solution, which could be Splunk or which could be a third-party solution, right? Could be a monitoring system that you have running in the cloud or whatever the case may be. So how do you extract the data that is displayed in Catalyst Center in this dashboard, but extract it and have it available somewhere else for your integration? So we have several endpoints for this. You see here, I'm showing 2 of them. So you can get the Power over Ethernet details using this API endpoint, the /DNA/intent API version 1 network device. You specify the device UUID and then /POE, and this would be the response that you get back. You get the power allocated, you get the power consumed, and power remaining for that specific device, right? You can also go deeper and get the power interface details for that specific device. So by specifying the interface name here, right? Actually, the interface name would be returned to you. The max port power consumed for each interface, the allocated power, and then the power drawn for each port. So then you can get a budget of power that's being allocated to that specific interface, how much is being consumed. So you get all this information from this API endpoint, right? So that is great. You get all this data, you have these API endpoints, but it's a bit cumbersome to work directly with the APIs, right? So what if you want to use our SDK? So with Catalyst Center, we have a Python SDK that you can just pip install. And you'll see here, it's still called DNA Center. We're migrating all our naming convention, right, from DNA Center to Catalyst Center. So that coming up is going to take a bit of time for us to move everything. But for the SDK, we have the POE_details, which maps to that POE details endpoint from that I just shown you, right? So using this function, you pass in the device UUID, and you get back that information in JSON payload with, hey, this is how much power this device is consuming. This is how much power has been allocated to it. There's also a function that covers the PoE interface details. For that same, it's a mapping to that API endpoint. And here you specify the device that you want to get the PoE details for, and also an interface name list. And you would get back JSON formatted nice object in Python that you can actually, after that, include as part of your solution wherever you want to have this data imported in. So that's our Catalyst Center Python SDK. What about if you're using something like Ansible, right, for your configuration management? Rest assured, we also have a Ansible collection for Catalyst Center. You see here I have the link at the top for the documentation for that collection. And we have 2 tasks that map also to getting the PoE information for the device and getting the power over Ethernet information for each interface in that specific device. So you see here, cisco.dnac.network_device_PoE_info would be the task within that Ansible collection that returns the information to you, and will be also nicely organized in JSON, right? You can take this and load it up in your third-party monitoring solution that you have running. Same thing for interface PoE information, right? This would be the Ansible collection, the task within the Ansible collection that would return the information, the power utilization for each interface in that device. That's all nice and dandy. What about if you have, and you're using Terraform in your environment, right? You're a Terraform shop, you're happy with it, then that's fine. We also have a Terraform provider for Catalyst Center. I have here the link. And we're also migrating the DNA Center provider in Terraform to Catalyst Center. That's also a work in progress. You will see we also have we have both of the providers right now, and going forward we'll be having and using only Catalyst Center as we migrate our customers to 237 and above. So you see here the data sources. In Terraform, this would be your get calls, right? So you would get this information from your Catalyst Center. The PoE for the device would be with, in this example, and getting the device interface power over Ethernet utilization would be done using this example right here, this example of HCL code. All right, so we've seen so far power over Ethernet utilization, very important information for us to know where we stand from a power consumption perspective, to know how to improve and lower our power consumption. So first, right, make sure you know how much you're consuming so that you know what you're trying to optimize. And if you have Catalyst Center and you're happy with the dashboard that it provides, that's perfectly fine. But keep in mind that we also have this information available over the APIs, right? And then you can integrate it with your third-party monitoring solution, or you can build automation around it. When power reaches this level, you can trigger specific actions, so you can monitor that power consumption in real time. And then I showed you, right, the SDK, Ansible collection, and the Terraform provider that we have for Catalyst Center. Going over next, so besides just showing you dashboards, Catalyst Center can save energy by using power profiles. So you can assign power profiles to your access points, for example, and when they're not used, or they're outside working hours, you can actually apply these power profiles that basically lowers the power consumption of these devices when they're not being used. So we estimate that using power save on 2,000 access points, right, and you're just saving 1.5 watts for 10 hours a day, which would be, overnight, 10 p.m. to 8 a.m., saves up to almost 55 megawatts hour of energy, and more than 43,000 metric tons of carbon dioxide emissions over 5 years. So this functionality, right, the power profiles, you apply them, is also available over APIs, right? So you don't necessarily have to use the GUI. You can use the wireless RF profile API endpoint, which is /DNA/intent/API v1 wireless RF-profile. And this is a post call. So this actually creates a new RF profile. And this is the payload that you have to pass in as you create a new RF profile using the API. So you see here, you have the option of enabling radio type A, B, or C, right? So 2.4 gigahertz, 5 gigahertz, 6 gigahertz, you can actually enable and disable them programmatically using this API endpoint. Even more so, you can specify the minimum power level for type A wireless, right? The maximum power level, same thing for type B, type C. So you can modify these, the parameters as part of the payload that you send to this API endpoint. So once you create the RF profile, you need to apply it to an access point group, right? So you would use the ap.provision endpoint, and you can find all these endpoints actually documented to this link, developer.cisco.com/docs/DNA-center. And we'll update this also as we go forward, the link. But you can find the documentation, how the payload should look, right? So all this information that you see, I've actually gotten from the API documentation that's available at this link. So this is the API endpoint. This provisions or reprovision access point and applies that RF profile that you've just created in the previous step. So you've created, right? You've turned on or off 2.4, 5, or 6 gigahertz. You can have this on a schedule, right? Same thing as the power save option in Catalyst Center in the graphical user interface. Same thing can be done programmatically. So if you want to integrate with something like our SDK, right? You can get that information. The RF profile, creating or updating, would be this function in our SDK. And that basically creates or updates the RF profile, but programmatically using the SDK that accesses that endpoint that I showed you. And then you would do an AP provision. And this is the function that would provision or reprovision that access point with the new RF profile and would shut down, turn off, or turn on those wireless networks so that you consume less power, you save energy, there's less emissions, you even save money. So it's better for the environment, it's better for the business, it's better for everyone. Same thing, right? We have the Ansible collection, as I showed you. And for this, the Ansible task would be to get the wireless, to create the wireless RF profile would be cisco.dnac.wireless_RF_profile. So you see quite a lot of options that can be passed in here. And you can enable true or false. This would enable or disable type A, B, or C in your wireless infrastructure. And then this would be the Ansible task that would provision or reprovision your access point and applying that newly created RF profile. So you can have an Ansible playbook, right, that runs on a schedule. You can have it as part of event-driven Ansible. Something happens, right? You want to trigger a playbook. You can also use that event-driven Ansible option with your power optimizations in your infrastructure. Moving on, the Terraform provider, right? This would be the resource in Terraform that would create a wireless RF profile, right? Same type of information you see, type A, B, C, false or true enabling, power levels, passed in, you can modify them here if you so desire for all type A, B, or C wireless. And you can use this as part of your Terraform plan, as part of your optimizations for power consumptions using Terraform. So this is creating wireless RF profile with Terraform, and this would be provisioning an access point. All right, this is how you would do it, and this is how you would apply the RF profile with Terraform. All right, so that covers Catalyst Center, right? We've covered our PoE data. We've seen how to get power over Ethernet data utilization on the switch level, at the port level, how to get the data using the SDK, directly using the API, the SDK, Ansible collection, Terraform provider. I showed you the example for all of these. Same thing with the power save, creating the RF profile, right? Enabling, disabling wireless networks or antennas within the access point itself, so that you can save additional power and be more sustainable. All right, moving on to Cisco Meraki. So let's see what Meraki has around sustainability and power optimizations. So on the Meraki MS switches, we have the options of configuring port schedules. So we can power on or off ports on the switch, right? So we can have this on a schedule. You see here in this example, we have a MS switch that has ports enabled from 8 a.m. to 5 p.m. every day. And outside those hours, ports are disabled, right? So they basically shut down. From 8 to 5, ports are on. Devices attached to those ports can get power, can get access to the network. After those hours, the powers are basically shut down. So you can create port schedules to turn off power over Ethernet to access points during off-peak hours at night when they're not used. So this is the graphical user interface, right? This is the dashboard. What if you want to scale this, right? This is done device by device or a group of devices. What if you want to do this programmatically? Well, there is an API endpoint for this. And the API endpoint for this is /networks. You specify the network ID, /switch, and then port schedules, right? So you apply this at the network level. You can find here the link to the documentation for this API endpoint. And this would be the payload, right? It's JSON formatted. You see here, give it a name. Then you have the port schedule. You specify each day, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. And then if it's active and the times that it's active. You see here on Monday, Tuesday, and Friday is active from 9 a.m. to 5 p.m. Well, in the weekend, it's shut down 24/7, right? So from midnight to midnight, the port is inactive. And also after 5 p.m. here until next day at 9 a.m., the ports are shut down in this example. So this is the API endpoint, the payload. You send the payload and you create a new port schedule for the network that has this specific network ID. Now, similar to Catalyst Center, we have, of course, a Python SDK with Meraki. You can find the link right here to it. Same thing, pip install Meraki, right? Very straightforward to get started with it. Documentation is within the SDK itself. So if you use something like any regular IDE will give you lots of documentation. This is the function basically that creates a port schedule, but with Python code, right? So you'd have create network switch port schedule. You put in the network ID, the name of the port schedule, and you can see these are both required. And then the port schedule object, that is that JSON payload that you tell that specific network, hey, I want you to have this port schedule for these times on or off. So that's the SDK. That's the Python function that you can use to create port schedules. And we also have an Ansible collection for Meraki. You can find the documentation link right here at the top. So for the name of the task, of the Ansible task that will create port schedules is right here at the top. So it's cisco.meraki.networks_switch_port_schedules. You specify your API key, right? The base URL, which would be like /v1. And then here, lots of options in the header. And as part of your authentication, right? You can pass in. Most of them have a default value, so you don't need to write it up, but you can also modify them. And then you create the name, the network ID you would specify it, and then port schedule in YAML format this time. So this actually continues up here on the right-hand side. So you have port schedule, Friday, active, Monday, Saturday, Sunday, right? Shutting down in the weekend, 24/7, those ports. So now, same thing, we have a Terraform provider also for Meraki that has recently been released. So with this, with the Terraform provider, you would use the Meraki _networks_switch_port_schedules resource in Terraform to actually create that port schedule. I have a link to the documentation here on Terraform, and lots of options supported over there. And by the way, what I'm showing you here is just a subset of all the things we couldn't cover in 1 hour, every single sustainability option and aspect of our products. This is just a selection of some of the ones I thought would be more interesting for folks. So right, you create here with Terraform your port schedules, you apply them to your network ID, and you're good to go if you use Terraform for your configuration management. So saving energy with port schedules, powering off, right? 1,000 power within devices and saving 10 watts, 10 hours a day is estimated to save 364,000 kilowatts hour energy and 76 metric tons of CO2 emissions over 5 years, right? Not only this, you also save money because you consume less power, and that is also good for the business. So that's the port schedules with Meraki. Let's go and have a quick look at powering off. So this is like, shutting down the ports on the switch completely. What if you want to do something similar to what we've done with Catalyst Center? Create an RF profile and disable all wireless on an access point, right? Or disable just some wireless configuration, some wireless networks or antennas that are on these access points. This would be powering off on wireless networks. So this would be the API endpoint that would update a wireless RF profile, radio frequency profile, right? So it's a /networks, specify network ID, wireless, RF profiles, and the RF profile ID. The payload for this API endpoint is quite verbose. There's lots and lots of options in there that you can specify, right? Access point band settings for 2.4 gigahertz. You can modify the maximum and minimum power, the minimum bit rate, the valid channels, right? Same thing for 5 gigahertz. You can modify the power for those wireless, for that wireless network, wireless antenna. You can specify the valid channels, which channels can be used. Same thing for 6 gigahertz, right? Specify power levels, valid channels, and you can enable transmission or disable it right here, right? And then you also have per SSID setting configurations that you can do, minimum bit rate enabled for which bands, 2.4, 5, 6. And you also have the model of your access point, MR34 in this case. All right, so this is the payload that you pass in. You can use directly with Postman, with curl. You can just send this payload to that API endpoint, and we'll configure your wireless network, enable or disable your wireless antennas on the access points. There's, of course, a function in our SDK that does the same thing. So update network wireless RF profile would be that function. You pass in the parameters, the network ID, the RF profile ID, and you create your payload, pass it on, and you can have this on a schedule, right? Disable your wireless at night, enable it in the morning when the folks come back in, save power, more sustainable. It's better for everyone. There's, of course, the Meraki Ansible collection, right? This would be cisco.meraki.networks_wireless_profile, sorry. So that would be the Ansible task that would configure your wireless, enable, disable your wireless at that level. And same thing with Terraform provider. We have this is the resource, right? You specify in your Terraform plan, I want my wireless profile to be configured. This is part of the payload. Couldn't really fit it on one slide, so I removed some of it, but you can find the documentation for this, all the parameters, the link right here on top. All right, so that was the Meraki section, right? We've seen port schedules. We've seen the API endpoint to enable. We've seen the GUI, first of all, how to enable port schedules within the dashboard. We've seen now the API endpoint that is actually used in the backend by dashboard to configure that port schedule. Then we've seen the payload. We had a look at that. We've had a look at the SDK, right? How to use the functions provided by the SDK to create that RF profile, to create that port schedule, the Ansible collection, and then the Terraform provider. So we've got configuration management tools, Ansible, Terraform. We've got the SDK, we've got the API. So we've got you covered in any case that you might have. So then moving on next to Cisco IOS-XE and sustainability features that are coming with IOS-XE. So Catalyst and IOS-XE powers telemetry for smart buildings. So smart buildings and Catalyst Center specifically are at the heart of enabling these buildings to become what we call smart, right? So you have here stacks of Catalyst switches, 9300s in this case, a stack of them, and you can extract metrics and telemetry data from these devices in several different ways. There's through a netconf interface, you can have a dial-in approach and get data that way. RESTconf interface will get you a REST API interface that you can interact and get metrics and telemetry data that way. And then GNMI and gRPC, we dial in and dial out as options with GNMI, and gRPC with the dial out option of the device sending you that telemetry data, whatever you configure it to, what server you're listening on. And then you send this telemetry data. It's being sent to a product like Cisco Catalyst Center, like we've seen, or you can build your Grafana dashboard. You could have a tick stack, Telegraph, InfluxDB, and Grafana that ingests this telemetry data. And we'll actually see on Thursday, if you join our second session as part of our Sustainability Week effort here, you'll see Jeremy Coho and Story DeWeese from the Cisco Catalyst IOS-XE BU, walking you through a hands-on workshop on how to configure telemetry, how to get the data displayed in Grafana with specifically a power component aspect to it. So our Catalyst switches at the heart of smart buildings. Telemetry data is critically important to know how much power is being consumed, right? And then also enabling us to create automation as part of our efforts to save on energy, save on costs, and be more sustainable. So which Yang APIs are used specifically from a sustainability perspective? These are some of them here. So you'll use the Cisco-iOS-XE-POE-Opper. So it's an operational Yang data model. And pretty much latest version of code that we have there has all these models already on the switch itself. Right, so you can get temperature data, fan speed, power supply, the PoE module, the PoE port, stack information, the PoE switch, so you can get utilization, memory, CPU, so on and so forth. And these are the XPath. So these are the path within the iOS-XE operating system environment where you can actually get this data from. So how do you discover these XPaths, right? Are they magical? So we have something that we call Yang Suite. So this is a product that will give you the option of connecting to your device, your Catalyst 9000 device, right? And then interacting with the device and being able to load all the Yang data models that are part of your device. Right, you see here, I've loaded up the iOS-XE-POE.Opper, that operational model, into Yang Suite. You can run Yang Suite in a Docker container or install it on a Linux machine. Here, I'm having it running in localhost in a Docker container, and I'm connected to a Catalyst 9200, right? And I'm loading up this operational model for Power over Ethernet. So you see here the model loaded up. You see all the options, Power over Ethernet for the port detail. And here on the right-hand side, you see the XPath. You see the prefix. So that's how you can easily figure out, right, using this tool, what's the XPath, how are these models looking, what are their options, how are the leaves organized, right, how are they grouped, what type of data I can gather from my iOS-XE device. So once you have this, right, you can load up multiple models. This is how it looks. So temperature could be the Cisco iOS-XE environment operational model. These are the options that come with there: the fan state speed, the power supply component states, CPU, PoE, the one that I've just showed you. Also memory usage over here. So explore, find the XPath. Once you have the XPath, you can go ahead and configure the telemetry. All right, so telemetry configuration, you see here, this is configuration over the CLI. You can do this over netconf. You can do the same thing over restconf. So you can configure programmatically your device in an automated fashion. So once you have from the Yang Suite your XPath, you can load it up and filter for that specific XPath in your subscription, in your telemetry subscription here. So that would be The prefix together with the XPath will give you, in this case, PoE, port detail information. So the power over Ethernet utilization for a specific port, for the switch overall, and if there's a stack of switches, the power over Ethernet utilization for the whole stack of switches, right? And once you have the XPath configured, you can configure also the receiver IP address. So this is your server, where you have TIG running, or that's listening for this data to come, that's telemetry data to come from the switch. You can also specify the source address, which interface is being used on the switch itself as a source IP to send that information to your receiver, and how often it should send it, right? This is on a 5-minute basis. So once you have this configured telemetry, you have your TIG stack running, you are able to get data similar to this, right? So you have your total power consumption for the device, you have per interface power consumption, and then you can see how much power at what times, and then you can build automation to shut down ports, right, overnight or when they're not used, and you can monitor your utilization over time and optimize your power consumption as you go through. So as usual, we have an Ansible collection with iOS. It's not as complete as the Catalyst Center and the Meraki one that I've showed you before, right? The Meraki and the Catalyst Center have pretty much a mapping of API endpoints. They're all mapped to Ansible tasks, or we'll see in a slide, Terraform providers. But with IOS-XE specifically, I'm using here the iOS command option to just send a show command to my switch, right? So there isn't necessarily a power enabled task within Ansible that you can use, but you can always fall back to cisco.ios.ios_command, and this would show and will send to the device, whatever command, CLI command you wanted to get output for. In this case, I'm using the show power inline, which would have an output similar to this, right? So it's not ideal. You would have to parse all this data and extract information that is valuable to you. But basically, this would be the output, right? You have a play recap here, connected successfully, it ran the command successfully, and that's the output. We also have a Terraform provider for IOS-XE. And while, again, there isn't anything specifically for PoE in Terraform, you can use the IOS-XE_RESTconf to send actual RESTconf calls. And by specifying the XPath, you'd get output pertaining to the power, right? So it's very straightforward. IOS-XE RESTconf or IOS-XE CLI. You can also use that to send show power inline commands, for example. And that would return data in JSON encoded, nice, that you can use as part of your Terraform automation. All right, so let me quickly see, are there any questions? We're getting close to, I'm just checking the chat window. Can we have access to this webinar offline? Yes, it will be on YouTube, available, the recording of this. All right, so those were the questions that I see. I saw just a quick message from Jeremy. Netconf, RESTconf example with Ansible 2. So Jeremy, I'm gonna let that for you to possibly show them on Thursday. But yes, Ansible also supports Netconf, RESTconf. So not only the iOS command that I was showing you, that's also an option if you're using Ansible for your automation. All right, so we've covered IOS-XE. right? And the Catalyst switches, they're critically important as we build smarter buildings. We need telemetry data, right? And I showed you the Yang data model specifically for power telemetry, how to explore these models using a Yang suite. You connect your device, you load up the models, you can go and explore, find the XPath. Once you have the XPath, you can go and configure the device either to the CLI with the telemetry streaming configuration or over netconf or over RESTconf interfaces, whatever you prefer. And once you have that configured, telemetry data is being sent to your server. Could be a tick stack, could be Splunk, could be any other solution out there, Elastic, ELK stacks, Prometheus, right? Whatever it is. You load up your telemetry data, you see where you stand, and you can start optimizing your power consumption, shut down ports, build automation around it using Ansible, Terraform, RESTconf, whatever you're comfortable with. So that was covering IOS-XE. Let's move on now. And in conclusion, right, sustainability is now more important than ever before. We need to make sure that we go towards our goals of net zero. You've seen at Cisco what do we do for this. You see our plan. We see you've seen our goal, the metrics, and then the data. Remember, that's what you need to do also in your infrastructure, in your environment, in your business. Make sure you come up with a goal, then metrics. Make sure that you follow those metrics and select the correct metrics to keep you on track and making sure that you're reaching your goal. And then the data, how important are the changes that you're making, right? The sustainability goals that you've set, how important are they in the bigger picture? Get data to back up those claims. So Cisco is committed to net zero across our value chain by 2040 with an intermediate step, like I said, in 2030. Powering off switch ports, right? Access points, or just antennas within the access points when not in use is very easy to do at scale with the APIs that I showed you, with the SDKs, with Ansible collections that we have, with Terraform providers that I showed you, right? So you can build automation, you can build schedules to automatically shut down your ports when they're not used, shut down your access points, save on power, save on money. There are several other sustainability use cases and workflows that are made possible by Cisco technologies. Like I said, we cannot cover all of them in just 1 hour. We have Meraki sensors. We have sensors for air quality detection, right? To make sure you follow that. And all those sensors have API endpoints associated with them. So you can also programmatically configure them, get data out of those. And also make sure that you are part of the solution and take part in the DevNet Build for Better Coding Challenge. All right, so like I was telling you, we've just extended the deadline for that. Check out developer.cisco.com/build-for-better. You'll see there the topics for this year are AI and sustainability. So there you go, Sustainability Week this week. Make sure you check it out. There's cool prizes to be won. There's some money that you get, some credit store for Cisco Store. There's mentorship from DevNet experts that you can also win. Bragging rights, of course. You'd be the first winner of our coding challenge. And this is, by the way, our first code challenge that we're running. So be cool if you can win that. And that's pretty much all I had, and some resources for you folks. So all the links that I've talked about, right, I have them here. Catalyst Center, the links, Meraki, IOS-XE, and I'll have under this GitHub repo all the snippets of Ansible, Terraform, right, and SDK code that I showed. You'll be able to find in there small Ansible playbooks for the examples that I showed you, Terraform plans, and also simple Python scripts using the SDKs that I showed you as sample code that you can go and just pick up and use them as they are. Any other questions? Let me see if we have. Yes. Hello, everyone from Morocco. Hello, Tariq. Is the Catalyst Center free to use for the 92, 9300 Catalyst on devices? Amit, I'm not sure. Is the Catalyst Center free to use? Oh, no, there isn't. So you used to have to purchase an appliance, which was a UCS C-series server that you get with Catalyst Center installed on it, right? So it was like this big appliance. And you would have to have, like 3 of them for high availability. But then we virtualized that. So now you can have Catalyst Center run as a virtual machine on VMware or QEMU or whatever virtualization platform you're using, and also in public cloud providers. So you have the option of running Catalyst Center now in AWS, right? There is a cost with the product, of course. There's a licensing after that. But Ahmed, it's not free, right? Catalyst Center, it's not. Shannon, thanks for joining the session. Hope you found it interesting. And that is it, folks. If there aren't any other questions, thank you all so much for joining. Join also on Thursday, like I was saying, the session that Jeremy and Story have put together. We'll be there. They'll show you how to configure telemetry specifically for IOS-XE, right? And show you how to ingest the data and display it in like a TIG stack in Grafana. And you can see your power consumption, and then you can build ways to optimize and lower your power bill and be more sustainable. Checking one more time. Develop one more thing. Can we add? Okay, so that is it. I don't see any other questions. Thanks all, folks. And like I said, make sure you join on Thursday also the session. And thank you so much. And take care, everyone. Bye.